This is 5 Minute Friday on the AI Scientist. Welcome back to the Super Data Science Podcast. I'm your host, Jon Krohn. I'm in a real big rush this week, so we are going to skip doing Apple Podcast reviews or reviews that we've received on the show in recent weeks. We'll do that again sometime soon. This week, we're just going to jump right into the meat of the episode, which is that a team of researchers from a company called Sakana AI, it's a Japanese AI startup founded last year by Google alumni, and that reportedly was valued at over $1 billion in June. So founded last year, and then about a year later, a couple of months ago, was valued at $1 billion by some big VCs in the Bay Area. Anyway, so that company, Sakana AI, this week published a paper titled The AI Scientist Towards Fully Automated Open-Ended Scientific Discovery. And that paper is making big waves and could revolutionize how we conduct scientific research as a society. The paper's authors, who, in addition to folks from Sakana, hail from the University of Oxford, the University of British Columbia, and the Vector Institute in Toronto, they imagine a world where AI systems can independently generate novel research ideas, design and run experiments, analyze results, and even write up full scientific papers. And while far from perfect, this new paper presents a comprehensive framework called the AI Scientist that aims to do exactly that, to automate the entire scientific discovery process from start to finish. Here's how it works. The AI Scientist uses large language models, surprise, surprise. Specifically in this paper, they use either GPT-4o from OpenAI, Claude 3.5 Sonnet from Anthropic, which, if you want to hear more about that, you can listen to episode number 798 of this podcast. And the other big model that they used in there was the open source Llama 3.1405B. And if you want to hear about that one, we've also got an episode on that. That's number 806. So they used either GPT-4o, Claude 3.5 Sonnet, or Llama 3.1405B to do the heavy lifting. These LLMs have already shown impressive capabilities in assisting human scientists with specific individual tasks like brainstorming ideas or writing code, but the AI Scientist takes things several steps further by combining so many steps of the scientific process all together. The system starts by generating novel research ideas in a given field. It then designs experiments to test these ideas, it writes the necessary code, and it executes the experiments. After collecting and analyzing the results, the AI Scientist writes up a full scientific paper composed with LaTeX, describing its findings, complete with figures and proper formatting. Separately, other than the AI Scientist, in order to evaluate what the AI Scientist was creating, the researchers also developed an AI-powered review system to evaluate the quality of the generated papers. This automated reviewer provides feedback and provides scores that are supposed to be comparable to human reviewers at top machine learning conferences like NeurIPS. In the paper, the team went on to then demonstrate that the AI Scientist's capabilities across 3 distinct areas of machine learning research, specifically diffusion modeling, transformer-based language modeling, and learning dynamics, they showed that based on judgments by their own AI reviewer, so perhaps take this with a grain of salt, they found that the AI Scientist across all 3 of those domains could produce papers that exceed the acceptance threshold for top ML conferences, again, like NeurIPS. And if you happen to be watching the YouTube version of this, I actually have figure 4 up on the screen right now, or you can check out figure 4 yourself. In that figure, they show across those 3 different machine learning areas that they had the AI Scientist do research in, they show the LLM reviewer scores for the different LLMs like Claude 3.5 Sonnet, GPT-4o, and Llama 3.1. And it's interesting, at least for this kind of use case with the way that these researchers set up the AI Scientist, it shows that Anthropic's LLM, Claude 3.5 Sonnet, is by far the best. And indeed, when you check out this paper or the GitHub repo, you can see that they primarily used Claude outputs for the example papers that they generated. And moving on to another part of the paper, specifically table 3, you can see an example for one of the research areas, specifically diffusion modeling that they created a bunch of papers for. You can see specific hard data on how things like they, all of these models, whether it was Claude 3.5 Sonnet or GPT-4o or Llama 3.145b, all of those were able to generate lots of ideas, but not all of those were novel. And so Claude was able to generate the most novel ideas. Claude was also able to get the most experiments written correctly with code in order for the experiments to pass and complete papers. So for example, in terms of completed papers, Claude 3.5 Sonnet created 38, whereas GPT-4o created less than half as many, only 16. And interestingly, the AI evaluator, the reviewer that they created, also gave a higher score, a higher mean score to Claude papers, and Claude also cost a tiny little bit less to run across all of those ideas and papers. And the numbers here are really small. We're talking about $250 for Claude 3.5 Sonnet to generate 51 ideas and have 38 experiments pass and write 38 completed papers. GPT-4o was a little more expensive at $300. So just some interesting data points there, and kind of sits with my own personal experience, my own personal preference right now for using Claude 3.5 Sonnet for the most use cases. Anyway, so yeah, on that note of cost effectiveness, one of the most impressive aspects of this whole AI scientist system is the cost effectiveness. The researchers report, based on those kinds of numbers I just said, that the AI scientist can generate full research papers for as little as $15 each. This kind of price point could dramatically expand access to cutting edge research capabilities. Although note that ML research itself would typically cost at least multiple orders of magnitude more than $15 to be executed. So maybe the paper writing itself could be much, much cheaper. And that's going to go down and down and down and down as LLMs continue to become more and more of a commodity and more powerful. Really cool on that cost front here too. However, of course, like any cutting edge research, there are tons of limitations and ethical considerations to work through here. The current version of the AI scientist is prone to errors and hallucinations. There are also valid concerns about how this technology could impact the scientific publishing ecosystem. If we just had tons of generated papers creating noise out there. And so the researchers, for example, emphasize that papers generated by AI systems should be clearly labeled as such. It does leave me wondering, though, if they become good enough, how do you tell and police that? Anyway, looking to the future, the authors of this AI scientist envision expanding its capabilities to other scientific domains beyond just machine learning. So all of the paper examples across those three distinct areas that I mentioned earlier, diffusion modeling, transformer-based language modeling, and learning dynamics, those are all machine learning research. So yeah, they envision that this could expand beyond that in the future. It could even be integrated with robotic lab automation. And so similar systems to this AI scientist could one day conduct actual physical real-world experiments in fields like biology, chemistry, and materials science. I encourage you to check out the full paper for more details on this fascinating AI scientist development, including to see for yourself full examples of the generated machine learning papers, some of which are at least superficially compelling as being human expert designed and written up. I've got a link, of course, to the paper in the show notes, as well as a link to the associated GitHub repo. The paper authors generously open sourced all of their code. On a final note, be careful using that repo. It includes the ominous warning. I'm going to read it in full. It says, "Caution, this code base will execute LLM written code. There are various risks and challenges associated with this autonomy. This includes, for example, the use of potentially dangerous packages, web access, and potential spawning of processes. Use at your own discretion. Please make sure to containerize and restrict web access appropriately." So that's the full warning. And be very careful to do that because, as covered by the mainstream press, the AI scientist displayed some fairly concerning power-seeking behaviors with implications for AI safety, including, for example, editing its own code to remove time constraints on how long a given agentic AI process it has can run for, allowing the AI scientist to potentially consume far more resources than its human creators intended. This kind of power-seeking behavior could be especially dangerous if a system with autonomy, like the AI scientist, had access to a robotic wet lab, a real lab where real-world experiments are being run, because then the AI scientist could end up manufacturing, say, novel and dangerous viral pathogens without us knowing about it. Yeah, so that is definitely concerning, and I've got a link to an Ars Technica article in the show notes as well for reading more about these AI safety concerns. And despite the risks, I, as usual, remain optimistic that we can work out safeguards around the most dangerous risks, and that this research represents a significant step forward towards realizing the potential of AI to be creative and productive in scientific discovery. While it's unlikely to fully replace human scientists anytime soon, the AI scientist and systems like it could become powerful tools to accelerate innovation and tackle some of the world's most pressing challenges, from clean energy production to food security to healthcare. All right. That's it for today's episode. If you enjoyed today's episode and know someone who might, consider sharing this episode with them. Leave a review of the show on your favorite podcasting platform. Tag me in a LinkedIn or Twitter post with your thoughts. I'll respond to those. And if you haven't already, be sure to subscribe to the show. Most importantly, however, I just hope you'll keep on listening. Until next time, keep on rocking it out there, and I'm looking forward to enjoying another round of the Super Data Science Podcast with you very soon.